said earlier today, the Internet of Everything is really a collection of technology and a paradigm for thinking about how we're going to have a digital sixth sense and how that's all going to come together, not only as a technology platform, but actually as an experience. What is it going to mean to have the Internet of Everything? What is it going to mean to have wearable computing? I was doing press earlier around the watch, and talk is actually something that is now part of my life because I actually miss it when I don't have it on my wrist. And there are things about it that are very different than you might expect if you haven't worn one before. It isn't about replacing your phone. It isn't about even sort of fundamentally changing the things you do. It's about making those things easier to do and possibly making some new experiences happen. And that's why we're going to open it up to developers. So today, in the talk I'm going to give you, I'm going to try to tease apart some of those concepts. If you start with something like an experience that we're experimenting with, what are the components that go together with that? What are the things that make up an ecosystem? Because this isn't just about creating a technology platform that is sort of vertically oriented towards solving one problem. It's about actually building an ecosystem. And that's something, if you look historically at what Qualcomm has done over the years, that's what we do. We build ecosystems. We create platforms so that our partners can innovate on top of them and drive unique and really exciting experiences to the end consumer. And we're trying to do that again with the Internet of Everything. And that's going to take a lot of pieces. One of the things that we really think is required here is heterogeneity. What I mean by that is that it can't just be a single brand experience. It can't just be a single technology experience. It actually has to be around interoperability. And that means that we can actually innovate in different kinds of cycles as the technology develops. Think about the Internet. It started off very early on wired technology and then broke into wireless technology, the things that Qualcomm contributed to, drove data right into the pocket. And now we're talking about driving data right onto your wrist. But the innovation happened because the layering of the web means that you can innovate and bring out HTML2 and HTML3 to HTML5 independently of what we did with 2G and 3G and 4G, and who knows what comes next. Possibly 5G, I don't know, you might infer that. We might skip to 6, though. So that heterogeneity, in addition to being a really hard word to say, is really the cornerstone of what makes that ecosystem, because you actually have people that come to it and innovate in ways that you never expected. One of the things that's most exciting for me about what we've been doing with AllJoyn, which is what I'm going to talk about mostly here today, and things like the watch, which has AllJoyn as one of its pieces, is we want to see what people do with this technology. What will you do if you have an always-on display on your wrist? What will you do if you can discover services and features and interfaces when you walk into a space that you've never seen before? What will you do if you can sense things about your environment, like your location, so that you're near something and you can get information and event-driven data? We don't know all the different ways this is going to happen, and that's exciting to us. If you think sort of back, sort of take a step back from that, we're not saying that the cloud isn't where it's at anymore. We're not saying that this is competition to the cloud. The cloud is still a really important part of this, but in a lot of ways we've sort of figured out how to use the cloud to virtualize our environment, how we make our information and our services come to us no matter where we are, whether we're driving in a car down the highway, whether we're sitting in our home, whether we're at the office, whether we're in another country. We can now get access to things that used to only be available to us sitting at a desk wired to the mainframe. So that's really cool. But sometimes what we really want to be talking about, and where we think the next level of sort of innovation is going to happen around, is interacting with things that are actually proximal to me. And that's what I'm going to spend a little bit of time going over for the rest of the talk, is what is the Internet of Things near me? So I was trying to think about this this morning, actually, of a way of describing it. And if you look at sort of the path that I walked us through a little bit historically, the beginning, the internet sort of started out as we really tried to get the body of the system right, the big trunks that went from place to place that let us connect. And I can remember when, in the United States, for example, the big places where all the internet service providers peered were really important because that's where the packet exchanges happen. And now they're everywhere. But you had, for a while, May East and May West, and those were really exciting places because you watch your packets, instead of going just where you think they should go as the crow flies, fly back and forth and then end up in the right place. But we got the body right. And then the next part of it, we wanted to reach out and have that data happen wherever you are. And I think that's sort of the arms and the legs of the system. And you see that with the phone that you have in your pocket and the mobile data. And I think where we're going with the Internet of Things near me now is now we're talking about the fingers and the toes. We're saying, how are we going to reach in and manipulate the environment that's near me? How are we going to take the tools that we have, the technology that we have, and make it work across all the things that I care about? And I care about them because they're near me, right? There are things in my home, things in my office, things in my car that clearly I care about because I've chosen to either buy them, put them front and center somewhere, or actually and use them on a day-to-day basis, right? So those things actually matter to me, and I can use those clues to leverage things that I might do in technology. But it takes a different kind of technology than what we use to build the body and the trunk of the internet. It can't just be about things that we've set up before. Even when you set up an internet, a wireless connection all the way to your house, for example, and you set up your Wi-Fi networks and soon the small cells that we'll be helping our partners build, you're still building something that's configured, sort of in a star shape, and it's sort of known how the packets are going to route. But I can walk into a room that I've never been in before, and I should be able to discover wirelessly things that are accessible to me. I should be able to say, I would like the lights to be a little bit lower. I would like the temperature to be a little bit higher. There aren't really any technology barriers to how we do that right now, but there are barriers to right now is that there isn't an ecosystem. What we have is a bunch of vertical approaches to this kind of ecosystem. And what we want to get to is a place where the things that are not important to differentiate on, we make interoperable, and that people can differentiate and add value at higher levels in the services stack. So we want to match the topology of what we're doing to the task at hand. Paul has said that sometimes it's not about the technology, it's about the topology. Right? So that star-shaped networks works really well for the things that we know and love. We can stream videos from YouTube, we can get pictures of the cats, we can surf Reddit, but I still have 5 things in my home, and my wife is actually in the audience, and she can attest to the fact that none of the things that I'm playing with home automation talk to each other. So we want to figure out how to break down that barrier. We also want to continue to use the cloud when the cloud makes sense. The cloud itself, there's nothing in what I'm trying to say about the cloud being bad. What I'm saying is the cloud does something that has to do with virtualization and has to do with sort of hiding location, and we want to actually exploit it to the finest degree. The fact that I'm 5 feet away from that podium should actually let me do some things that are different than if I was in the other room. So together, if we can think about that boundary between what we think of as the internet near me, the proximal cloud, and the relationship to the bigger cloud, I think we'll get systems that have some really interesting characteristics. Right? One of the things about the proximal cloud that is very different than the big cloud is that it's dynamic. I never know what I'm going to discover when I walk into a new place. I never know when I'm going to add another device or another service to things that are near me. I'm hoping that happens all the time as software gets upgraded, as devices come out into the marketplace. I don't want to have to decide now what my refrigerator is going to talk to when I have it for the next 10 or 15 years. I want to think about those things in advance, do a good system design, and then go from there. So that dynamic behavior is something that is actually critical to what we're going to do with the proximal cloud. And that's kind of what drove us to the design of the parts of the system that really led to what is now all joined. So maybe I'll walk through a little bit about that design. I'll come back to that relationship between the cloud and the proximal cloud and talk about what we think is appropriate to have at sort of that barrier, that membrane between those two things. And we're going to talk about security and privacy and scale. So the first thing that actually drove Alljoin's design is about 3 years ago, we were thinking about how can we make it easier for our customers that are working on applications on Android phones, because this is just when Android came out. How can we make it easier to build multi-device experiences? Qualcomm's a wireless company. We don't want you plugging cables between the devices. And it wasn't that easy to have a software developer who was using this rich environment that was provided by the smartphones, Android, iPhone, and others. It wasn't easy to build these multi-device experiences. You had to really know how Bluetooth worked or really know how Wi-Fi worked. And it should be easier than that, because if I'm building a website, I don't actually have to know the guts of TCP/IP or how Ethernet works, right? I can just build these systems because of all this nice layering in there, all these really good toolkits, and we wanted to provide the same thing. But we had to think about different kinds of systems and different kinds of features, because the Internet of Things near me is ad hoc, right? I don't know what it's going to be. So we built a system that was based on discovery, and it was based on strong security principles. And we also tried very hard to think about scale. Because one of the things we believed is if we started to do this and it caught on, there wasn't going to be sort of a limit to what we're going to do. If every one of our devices was talking to each other in this room, the system should scale to that kind of size, right? If I go from having 2 devices in my home that have an internet address, an IP address, to having 20, to having 200, to possibly having 2,000, even though some of those things, some of those 2,000 nodes are doing very, very tiny bits of functionality, like sensing a door is open or closed, right? Or setting a temperature for me, or making the water heater communicate with the dishwasher so there's enough hot water for both the showers and washing the dishes. Some of those things are really small, but I have to build a system that can build that kind of scale. Turns out Qualcomm's really good at scale. So we thought really hard about what kind of networking technology we would put underneath that. The other piece we're really interested in is thinking about security, right? Think again what I talked about. Some of the devices I'm going to be talking about are really, really small. Small means a couple things to people that actually work in the electronics industry. Small means generally inexpensive, because small things people generally don't pay a lot of things for, or a lot of money for. And the other thing is that small sometimes means very limited capabilities, right? So I'm not going to want to take this very limited capability device and basically say the way I'm going to talk to that door sensor is by making it accessible on the public internet. It might be something that I can technically do, but I probably can't do it at the price point that I want to do, and I probably am exposing myself to a security risk by doing it. Not because the people that build these devices don't know what they're doing, not because you can't build a secure door sensor. It's because what we think about in security is surface area, right? Why should I expose thousands and thousands of devices in my home in a place that I know is private? Why should I expose them to the public internet and give attackers, give hackers, give bad actors that surface area with which to attack my home? Why would I do that? Why would I do that in my car? Why would I do that in my office? There's no particular reason to do that, other than it's kind of easier right now to push everything into the cloud and do the business logic there. Well, our premise was with AllJoin that the network of the future was actually going to be a collection of things that are connected through the cloud and ad hoc networks that are very personal to you. And we're actually going to have to think about those hard algorithms to deal with the fact that the ad hoc network and the big structured network have a relationship, and we should define that relationship very carefully. And that's a little bit different than the view that some people take out in the internet world, maybe in parts of California further north than here. You know I can't say those words. The idea here is that we actually want to think about what we're going to do to build a system so that as we get developers out there, as we get members of the maker community out there, they don't inadvertently build systems that are insecure or violate privacy. We want to structure the system from the beginning to say, you know what's really important? Security and privacy. So by default, we're going to build a system that lets things that are near each other talk to each other and doesn't talk to the public internet. And when you want to talk to the public internet, we'll put a gateway or a service or something that can have that security right at the edge. And then you can say, you know what? I sometimes do want to set my thermostat when I'm away. By the way, I don't actually ever want to set my thermostat when I'm away, but you can. I turned again, I think my wife would be pretty upset if I started playing with the temperature while I was over in London tomorrow. But I might want to do certain things. I might want to say to my house, I'm not going to be home for a while, go into power saving mode. Or I'm not going to be home for a week, make it look like I'm not there. Those are kind of high level interfaces to a proximal cloud that are well abstracted and well understood. I shouldn't, from the other side of the world, have to say, light bulb number 43, turn on at 12:15. Right? That's the wrong interface. That's the wrong system design. So we thought about with AllJoyn is let's build a system that solves the hard problems of how these devices are going to discover, talk to each other, and be secure within proximity, and then see how people construct systems on top of that to get to the next place. So that really talks, that architecture speaks to both privacy and security at the same time. I don't have to worry that information about which lights I turn on when, what TV shows I watch, what the temperature of my house is leak out into the public world, and people can either infer things about me from that, right? If I want them to, I'll expose that information. The other part of the system that we really thought hard about is programmability. Oftentimes, and historically, a lot of ways that we've worked in the hardware world is by saying, we're going to build this communication system. And by the way, the cellular networks were not built this way, but I'm talking more about the local area stuff that we've all used. We're going to build a system, and what we're going to do is we're going to define a radio, and we're going to say, this is what you can do with the radio. And if you want to change that, we're going to get into a standards body, and we're going to sit for 2 or 3 years, and we're going to define a new thing that happens. And if you want to think of another thing that happens, we're going to repeat that process, right? And that's all well and good when you're trying to build on systems that have really sort of limited resources and very sort of special purpose functionality. They want to solve a particular task. We'll contrast that with how the internet and the web works. The internet and the web works by saying, here are foundations. This is what we're going to use to communicate. We're going to use HTTP. It will go across a variety of physical systems to get from one place to the other. But if you put a packet in at one end, at the other end a packet pops out. Start with that and go from there. And then you layer on HTTP and HTML and JSON and RESTful APIs and all these things the developers use when they build large-scale systems on the web, and you get some really interesting pace of innovation. If I have those tools, I can innovate so quickly on the web and so quickly with those kinds of services, now so quickly in smartphones. How do we do that now with devices? So one of the things we thought about with AllJoyn is how do I bring that level of programmability down onto devices that have traditionally been sort of using very purpose-built protocols and things that were defined and take years and years to change. So AllJoyn is actually designed like a bunch of computer science systems that made the web work, where AllJoyn itself can actually think about how do I speak to something by saying what interface do you expose. So in AllJoyn, for example, if you're trying to find a printer, you don't say, is there anything whose name is printer? Right? Which is the way a lot of systems have traditionally worked, and that's a good thing. What you say in AllJoyn is there anything out there that implements the printing API? And if you're really particular, you can say, anything out there implement the printing API version 2, because that's all I know how to speak. All right? But the other thing you can do is you can ask other devices what interfaces that you have. So you can actually discover things about the capabilities of the devices near you and maybe put them together in ways you weren't thinking about before. So that programmability, which is hard for me to stand up in front of everybody and talk about without pictures of source code and inheritance diagrams and delegation. But that programmability, the key takeaway that I hope you hear from this is that we designed the system to actually be able to describe itself. Right? And the reason that we did it that way is because we want to future-proof the system so that in 5 years, somebody will say, I didn't think when they built that about that refrigerator that would be very interesting, but now I want to use it and I want to discover things about that. Or a software upgrade goes to that microwave and I can now do things with it because it exposes more APIs, more interfaces. So that kind of dynamic behavior is something we're used to on the big capital I internet, capital C cloud side of the world, but we're not so used to thinking about with devices, and we're trying to bring that level of sophistication to that class of devices, right? With that programmability, though, you don't want just a complete and open Wild Wild West. Interoperability is based on knowing that there is going to be some basic level of interaction. Now, those building blocks are really important. right? Sometimes building blocks in technology that have driven ecosystems were never even contemplated that way. I seriously doubt that when Tim Berners-Lee was thinking about HTML, and he decided that when I want to draw an image, when I want to let somebody insert a graphic into an HTML page, I'm going to let them refer to that image with a full URL. Okay? He was probably like, well, I'm building a system for consistency. I'm going to use a URL as address everywhere. That sounds all very nerdy, right? And you're probably wondering why Rob's talking about it. The point here is that that little decision that Tim made when he did that, Sir Tim, sorry, led to the entire internet advertising industry. Because I could build a website over here and refer to not only an image somewhere else, but a process, a program, a system that produced an image. And I could, over here, be an advertising network, and over here, be whatever website I wanted to serve ads on, right? But it was built because they're general purpose things underneath. So the next thing we tried to do with AllJoyn, and what we've been working with our partners on, and we've been talking to people who are actually building devices in the industry, is we're trying to say, what are interesting building blocks to start to build the Internet of Things and the Internet of Things around me? And we want these things to sort of cross between what we can all sort of see, sort of a clear line of sight to, like what Paul announced this morning with Uplinq, wireless audio, soon at some point wireless video, in a standard interoperable way. Something that didn't come out maybe in the way Paul talked about it, because Paul was talking about the experience, is underneath that technology is an independence from the physical layer. So AllPlay works over Wi-Fi, it works over cellular, if you set up an AllJoyn system on top of a cellular network. But more importantly, over Wi-Fi, Wi-Fi Direct, Ethernet, Powerline, whatever collection of networks that you have, so that you can build the system the way you expect to build the system. Right? So we talked about that building block, that media building block is sort of an obvious one. And then there are other ones that maybe they seem obvious, but they took us a while to sort of get to. One of the things we wanted to do was sort of something to help us build the ecosystem was make it easy to get things onto the network. It's really hard to get all these little devices generally onto a network, especially if it's a wireless network. So we built a service where you can use the user interface of your tablet or your cell phone to onboard. But it's a small building block that you can compose into an experience. Another one is a simple system called notifications. Notifications you can think of as the SMS for the devices that are near each other, in the car, in the home, in this room, right? Sometimes you want to send a message that just gets sent out. And you don't know where it's going to land, but you hope that somebody else has a display to handle something. So when my refrigerator wants to say you left the door open, it could beep really loudly. Or it could also send a message out on the local network, you left the door open. And if I'm watching TV, or if I have my smartwatch, or if I have that magical surface paint 10 years from now that somebody's going to invent that's going to change the wall of my house into a display surface, it can say, the refrigerator says who left the door open. And the refrigerator company didn't have to know anything about the technology that was used to display it, because we have that small composable building block. Sort of an analog to how businesses were driven on top of SMS. When SMS was first invented, it was so operators could send messages to their customers, right? It never was sort of designed to be the end consumer system that it was. But yet we created American Idol-like systems on top of it, all kinds of user experiences, all from building that primary interoperable send a chunk of text around. So notifications in AllJoyn are like that, but in the device space, right? So there are a couple other pieces like that. We have a control interface that allows you to say, as a device, here are the things that you can manipulate on me. I have an on-off switch. I have a slider, which is called temperature. Do something with that. What's cool about that is that I can not know anything else about that device, and I can walk up to it with my tablet or my smartphone. I can ask it about itself. It describes it to me, and I can build an interface to that. So other people, and other people like you, hopefully, in the developer community, can use that information to create experiences. And you can do that across brands and across ecosystems. You don't have to think about, well, this is what I do when I'm talking to a TV, and this is what I do when I'm talking to a washing machine, and this is what I do when I'm talking to a dashboard of the car. So with AllJoyn, what we're trying to do is say, here's a technology platform. We don't know how these things are going to mix together, But we do know that if we have an interoperable platform that can describe itself, that can introspect, that we've gone a long way towards that. And so that Internet of Everything ecosystem, we think, will be founded on top of that interoperability and that interconnectivity. Now, for those of you that don't know, one of the ways that we're also driving this out is we're making it available as an open source project. So you can go right now to alljoin.org and you can download alljoin. You can, if you're working with consumer electronics companies, talk to them about whether or not they're using alljoin in their future plans. I can tell you a bunch of them are. And you can think about, what would I do if I didn't have to worry about, well, this is how you talk to this brand and this is how you talk to that brand, and where we could get to. And I think as a community that builds, experiences and services, we can actually do some really interesting things. Let me give another example that I think for me is particularly interesting. We talked a little about audio. And so it's really cool. We built a system that you can stream audio. There's actually an open source audio streaming protocol that's out there on alljoin.org. So I can build a wireless speaker and use Wi-Fi to do that. And I can have 4 different music players. You saw that we worked with the Rhapsody guys to already put it into their application. That application, what they put into Rhapsody, would talk to any brand of wireless speakers that use the AllPlay technology based on alljoin. Well, what's the experience, though, beyond that, right? What does it get you to have built that audio streaming protocol on top of something like alljoin, which is, in fact, more complex, a simple system that would have just gone between point to point, right? What have you gotten? Well, one of the things you could get is, if I have a wireless speaker and I want to change the volume of the bass and the treble, I could actually expose those interfaces on alljoin, and while I'm streaming audio to it, I could build another interface to do that, right? The other thing is I can use other technologies and make them work together. For example, I could use the Wi-Fi in that wireless speaker, based on some of the technology we have in our Theris group, to actually not only be connected to the wireless network that's here, but sort of expose a Wi-Fi interface that is public if you're near me. Let me just walk you through that. What's the experience that you actually want if you're in a home or in a car? When your friend wants to play a song for you. The one I particularly use an example in the car is, one of our daughter's friends gets into the back seat of the car and wants to play a song. And usually, given the way our youngest daughter is, it would be for about 15 seconds and they would play a second song. But you don't really want to pair that person's phone to the head end of your car. You might not ever have that person in your car again, right? But yet, the proximity implies permission in a lot of ways. I'm old enough that the way that we used to manage the radio in the car was whoever could reach the buttons on the radio in the dashboard. And if you changed the station every 5 seconds, your mom or your dad would slap your hand, right? So I don't need to build a system around this proximal environment that makes me have passwords and pins and accounts and certificates. What I need is a system that says, if you're in the car, if you're in the room, you're allowed to play to those speakers. And as soon as you walk away from them, as soon as you get out of the car, as soon as you leave my house, you lose that privilege. Well, it turns out we actually know how to build that system. But it's hard to build that system if the technology it's built on only thinks about audio and not about connectivity and programmability and the Internet of Everything, right? So by having a richer substrate underneath all of this, we get to build experiences in ways that we might not have thought about building before. Similar to the way that we didn't know what people were going to do with web pages when we put all that stuff together. Really good experience designers build really amazing experiences on top of the web. We want people that are building physical objects to be able to do that same kind of thing by concentrating on ID and experience rather than how do I get these 3 bytes from this device to that device. And that's what we've really, really done with alljoin. So, I hope that gives you sort of in some ways, a philosophy of what we're doing with the Internet of Things near me. Because I think it's important to understand it not just from a technology standpoint. I could have stood up here and say, here's the mesh network protocol that we use, here's how we compare to SSDP, and I could layer a whole bunch of acronyms on top of it. Because those are things we thought about. We thought about, how do I make this work from something the size of a laptop down to a refrigerator, down to a light sensor. And I want them all to speak alljoin. So it can't be a giant protocol or code base. We have a version of alljoin that runs in 30K of code on an embedded Wi-Fi SoC. Right? That's, for those of you that aren't programmers, really small. All right? But it has all this functionality built on top of it and communicate with all that. So when we built that system, we really wanted to get to the point that we could then compose these things together so that people could build those experiences. I think now I'm going to talk a little bit more about where we're going with AllJoyn. Next week, actually, later this week, I'm actually going to Berlin to the IFA conference, where we're going to meet with a bunch of companies that are interested in actually building an industrial alliance around AllJoyn and related technologies to start that interoperability platform. And these are companies that are interested in building great consumer experiences, but not needing to differentiate on how the communication happens in between, right? And we think that's really exciting because it will break through sort of the vertical boundaries that a lot of the environments have been built on top of. We're going to think about things beyond what Paul showed earlier today and the services that I just talked about. We talked about audio. We're very interested in what it means to move video around because we think video is both a composition of things that you're going to deliver from the cloud into the environment and also things that you want to move around, like security cameras or video telephony and a whole bunch of other things. We want to think about general purpose media. We want to think about how we get people that are building things related to heating and cooling to interoperate with each other so you can compose systems that work together instead of having to do single brands. So all of these things are going to go on both in technology working groups and hopefully in that alliance that we're getting to. So if you were interested in this, there's a bunch of AllJoyn stuff that's out there in the demonstration rooms. We're going to talk about how you can use the devices that are around you to control and introspect and talk to each other. We're going to actually then have specific breakout sessions. So I'm going to read off the monitor for these, so I want to get them right. There's going to be an audio breakout session on AllPlay later on. I think that's today. There's going to be a demonstration of using AllJoyn to drive multi-screen experiences. So if you think about TVs that have a lot of functionality, laptops there, how do we build experiences that involve those multiple screens? And we've previously shown at Mobile World Congress and at CES things that we've done with the Sesame Workshop and with NASCAR. And so we've got some of that and some more stuff there. We have a more M2M session. You know, I've spent a lot of time talking about AllJoyn. We also are thinking about the really direct M2M connectivity that relates sometimes to AllJoyn and sometimes relates to other standards and the internet in a way that really what we're providing is the best connectivity and platform for that kind of scenario as well. There's going to be a session on the 3G and 4G modem connectivity that we have with that. There are going to be some specific talks about environments that we've built on top of our newer modems that let you actually do a lot of that work in a single chip so you can build these really great connected M2M solutions. We're also going to talk about the relationship between the cloud and the proximal network, where you might have the backhaul to the cloud be over that cellular link and actually on the inside, you know, sort of facing part of the network be speaking AllJoyn. Right? So those things actually work together. And I will remind you, Paul pointed it out, but I want to say it again, there is a demonstration called the AllPlay Chill Zone to demonstrate the audio parts. If you've downloaded the conference app, it actually has AllPlay in it, so you should be able to go and play your music on the speakers in the Chill Zone. So that's really where I wanted to get to about sort of the background of AllJoyn, rather than just being about the bits and the bytes. I really wanted to talk about why Qualcomm is thinking about this problem. And it's because it's a hard problem. And it's a problem that may not have a solution that we actually have full visibility to right now. But what we've learned from the things that we've done inside of our company and with our partners is that we think the solution has a different shape than what we've already done, and we want to experiment with that shape. So you can think of AllJoyn as our first answer to the question, what is the HTTP of the Internet of Things? And hopefully, with a bunch of you, we'll continue to make it better, and we'll actually take it to that next level. So with that, I'd like to open it up for questions. There are microphones here and here, and I'd be happy to talk.